choose to go to the moon, we all just get figured out.
We have achieved the earth-shaking, the breathtaking, the groundbreaking, and left a mark in the heavens. Our successes build one upon another and amplify what is possible. It's time we take the next great leap. We're building the next chapter of American exploration, returning to the moon to stay, so we can go beyond to Mars, to expand what's possible and further our understanding. The architecture for these missions is already taking shape. We will go with new systems, bold designs, and a sustainable mission. You can hear it, taste it, touch it. We are going. We are training, testing, pressing our pioneering spirit into every component, defining our resolve with every line of code, and securing our success with every welcomed partnership. This is not hypothetical. This is not about flags and footprints. This is about sustainable science and feeding forward the advance of the human spirit. Because we are the pioneers, the star sailors, the thinkers, the visionaries, the doers. And because we stand on the shoulders of giants to go farther than humanity has ever been, we will add our names to the rolls of the greatest adventurers in history. Every day, every mission, we advance this goal. We are NASA. And after 60 years, we're just getting started.
Tough act to follow. They were outstanding. Well, good afternoon and welcome to the Kennedy Space Center in the dawn of a new era in the exploration of the moon and Mars. I'm Bob Cabana, and I have the privilege of leading this amazing team at America's premier multi-user spaceport. I'm pleased to welcome you all, distinguished guests, NASA's valued employees watching from across the nation, and our media guests here and abroad. It was 50 years ago, this July, that KSC was the launch site for that historic Apollo 11 mission. When President Kennedy stood before a joint session of Congress and he announced his ambitious goal of sending humans to the moon and returning them safely, we still had to figure out how to make that work. We quickly ramped up operations here at KSC. We had the Mercury 7 crew here. We hosted them. We worked hard on Gemini, learning everything that we needed to know to get humans to the moon, to make those first steps on the lunar surface 50 years ago. We'll be making similar incremental steps as we build a sustainable architecture to reach our goals of the future. The team here at the Kennedy Space Center is up to the challenge, and we can't wait to see rockets on those launch pads taking humans back to the moon and eventually onto Mars. It's my pleasure now to introduce our administrator, Jim Bridenstine. Now, Jim came on board about the same time that the President signed Space Policy Directive 1 that directed us to send humans to the moon for long-term exploration and utilization, followed by missions to Mars. His passion for flight and space exploration served him well on the Armed Forces Committee and the Science, Space, and Technology Committee in Congress. And today, that passion is inspiring the NASA workforce and the public on a new mission of exploration. Please welcome our 13th Administrator, Jim Bridenstine.
Well, Bob, thank you for that great introduction, and thank you all for being here on a day that I think is extremely exciting. Today we are rolling out the President's budget request for NASA, and I am very happy to tell you that NASA's budget request from the President of the United States is strong, and we have strong bipartisan support in both chambers of Congress. Now, many of you know that I'm a Navy pilot by trade, and I'm going to spend a few minutes talking about a mission that I think is a lot of fun, very exciting, and transformative, as a matter of fact, for the way we fly in the United States of America. We have been plowing through the atmosphere at 0.6 Mach for 70 years, and I think it's time we change that. And the X-59 is our tool to do just that. In this budget request, the X-59 and the Aeronautics Research Mission Directorate is funded at a very strong level. I want to talk for just a second about what this means. Last year we saw, really for the first time, a test over Galveston in a populated center, what a sonic boom will do to communities, both from just an annoyance perspective and maybe from an infrastructure perspective. And when we saw that, we were able to make determinations as to what the level of tolerance would be for a sonic boom. It has been banned for a long time by the FAA to fly over the United States at supersonic airspeeds because of the disturbance and the problems with infrastructure. Well, we at NASA are working really hard to change that. And the low boom flight demonstrator is the tool to make that happen. In this particular case, we are assessing what is the tolerance for a low boom, and we're imaging it. In fact, just the other day, we had a B-200, a Beechcraft King Air, fly with a brand new camera and look at two T-38s flying below it at supersonic speeds and looking at that pressure wave. Not just at the bow, but at all different parts of those T-38s, and how those pressure waves combine. Because when they combine, that's when we get that really loud supersonic boom that can be disturbing and, in fact, troubling for infrastructure. So what we're doing now is we're going to take what we learned from these experiments, and we're going to apply them to the X-59, which is going to ultimately be flown in the year 2021, so that for the first time, we can get regulations on the books in the United States of America that say you can fly supersonic. And I think this is important. The X-59 is going to fly at Mach 1.4 at 55,000 feet. We're going to be able to go from one side of the United States to the other side of the United States in a couple of hours rather than 5.5, 6 hours, depending on the winds. This is transformative for how we are able to get from one side of the country to the other and travel within the country. Just as exciting is another mission within the Aeronautics Research Mission Directorate. This mission is the X-57 Maxwell, the first all-electric transport aircraft capable of carrying passengers and cargo. All electric. What does that mean? That means we can drive down the cost of transporting people and cargo from one place to the other by up to, and even in some cases, over 60%. Well, if we can drive down the cost by that amount, that means we're going to have potentially commercial flights going to more destinations than ever before. We're going to be able to serve communities with air travel that historically have not been served with air travel. I want to be clear, we are not there yet, but the X-57 Maxwell is the tool by which we will be able to accomplish these objectives. And driving down costs and increasing access to air travel is the way that we're going to be able to increase the standard of living for every American. And that's really what NASA is all about, elevating the human condition, and the X-57 is a tool to accomplish that. One other very exciting project within the Aeronautics Research Mission Directorate that I'm really kind of intrigued by is urban air mobility. The idea that you can fly on an unmanned, I should say, uncrewed craft, no pilot, let's say that, from one side of the city to another side of the city, just like you would drive a car. Now again, we're not there yet. But in order to achieve that day, we first start with cargo. And there is industry in the United States of America right now very excited about that eventuality. Why? Because it will help them get your packages to your doorstep faster and more efficiently than ever before. And once that happens, there is no limit to what we can do with humans in the future. But in order to do that, we have to be able to integrate uncrewed systems, unmanned aerial systems into the national airspace system. That's not an easy feat. When you're talking about doing it in urban environments, there's a whole level of safety that has to come into play. And so what NASA is doing within the Aeronautics Research Mission Directorate is working on those very challenging problems so that one day we're going to be able to deliver packages to your doorstep in a vehicle that flies in the sky over populated centers more efficiently, and even one day fly humans from one side of the city to the other. So these are all very exciting things within the Aeronautics Research Mission Directorate. And I wanted to make sure that I started the speech today talking about that part of the budget because as a Navy pilot, I like the idea of everybody being able to fly supersonic, and of course, everybody being able to fly in general, and eventually everybody being able to fly from one side of the city to another side of the city. So let's take it up a notch from aeronautics to space. We have seen what happens when we, as NASA, in low Earth orbit, we become one customer of many customers in a robust commercial marketplace in low Earth orbit. We just saw a SpaceX Crew Dragon dock with the International Space Station, deliver some cargo, namely a little Earth humanoid, ultimately do a lot of tests, undock, fly home, and land safely. That is a first step in a much longer mission for NASA to become one customer of many customers in low Earth orbit in a robust commercial marketplace, and at the same time having numerous providers that are competing on cost and innovation. Why is that so important? Because we need to drive down costs. We need to increase access. We need to make spaceflight more available to more people. That includes commercial activities. We're talking about manufacturing. We're talking about tourism. We're talking about pharmaceuticals, maybe fiber optics. We need to develop that very robust commercial marketplace in low Earth orbit. It starts with cargo. It is now starting to get to the point where we're going to be launching crew. By the way, we're going to do that in 2019. And eventually we're going to get to a day where low Earth orbit in general for habitation is going to be commercialized. In other words, NASA will be a customer of many customers with numerous providers competing on cost and innovation, not just for resupply, not just for crew, but in fact for habitation, for science, for discovery, for capability in low Earth orbit. Let's talk about why we want to do that. Why does NASA want to commercialize low Earth orbit? It is in our interest to take advantage of commercial marketplaces where they exist because the costs go down, access goes up, And then we can use the American tax dollars, the resources that we are given by the American taxpayer, to go further and do more than we've ever done before. That's who we are, and that's what we do. The President has given us Space Policy Directive 1, which says to go back to the moon, and we're going to do that in short order, maybe even in 2019, but at least by 2020, with commercial lunar payload services that are going to be funded through the Science Mission Directorate. And all of this is going to be possible because we're looking at going fast. There's two things when we talk about commercial lunar payload services that are important. Number one, it's commercial. We want competition on both cost and innovation. And number two, it's going to be fast. NASA is not going to be the long pole in the tent. NASA is going to, we have already provided 10 different payloads that are ready to go to the moon. And very soon, we're going to be issuing contracts to companies to deliver those payloads. We're talking about small scientific instruments to the surface of the moon. Now, Space Policy Directive 1 is not just about delivering small payloads to the surface of the moon. It's about much more than that. It's about having a sustainable human presence on and around the moon. In order to achieve that objective, we need a permanent command and service module in orbit around the moon. We call it Gateway, and that's fully funded in this President's budget request. I hear people sometimes say, well, you know, Gateway is not a space station. It is not. It is a command and a service module. But it will have the opportunity to have crew. The other thing that's important about Gateway is it's going to utilize solar electric propulsion to be maneuverable. When we go back to Apollo, we remember that we landed 12 astronauts on the surface of the moon over a period of 3 years, 1969 to 1972. Each one of those missions was to the equatorial regions of the moon. And because of that, we never went to the poles. Well, there's a lot of valuable material at the poles, namely water ice. We discovered it in 2009 in massive quantities, hundreds of millions of tons of water ice at the poles of the moon. Well, what Gateway represents is an opportunity not just to go to the moon over and over again in a sustainable architecture, but it represents an opportunity to get to more parts of the moon than ever before. Our goal is not just to land in one spot of the moon and learn a whole lot about all of the things that are happening in 1 kilometer around that one spot. What we're interested in doing is learning all about the entire moon. Friends, there is a lot about the moon we don't yet know, and Gateway is going to allow us, with this reusable command and service module with solar electric propulsion. It can be in that equatorial region, that near rectilinear halo orbit. I was told by my comms folks never say that word because nobody knows what it is, but I just said it. But it's also going to go to the poles of the moon. It can go to the north. It can go to the south, L1 and L2, giving landers, rovers, robots, and humans more access to more parts of the moon than ever before. We don't want to miss anything ever again. There's a lot to learn, and this is about sustainability. When we talk about sustainability, what does that mean? That means we need to be able to launch mass payloads off the surface of the Earth. We need the SLS, and we need the Orion crew capsule, and we need the European service module, all of the above. And some people say, because I have said quite regularly, when the President says go to the moon, and he says go sustainably, in other words, this time when you go, you need to stay. When the President says that, what does it mean? It means we need reusability. We have seen what happens in low Earth orbit when we reuse rockets. The costs go down and the access goes up. We need reusability in the entire architecture between the Earth and the moon. Reusable launch, reusable tugs, reusable command and service modules in orbit around the moon, reusable landers, robots, rovers, all going, human landers going to the surface of the moon. Everything needs to be reusable, built into the architecture. And that's really what Space Policy Directive 1 is all about, a sustainable return to the moon. But I have heard criticism that maybe when we talk about sustainable and reusable, why do we build SLS and Orion? Well, to be clear, Orion, by EM4, is going to have a lot of its components reusable, and we're working hard with our partners over at Lockheed Martin to make sure that we're building as much reusability into those vehicles as possible, and by EM4 it's possible. I'm not going to put a probability on it, but we could actually be reusing the pressure vessel of Orion in the near future. That's going to help us build reusability and sustainability into the project. When it comes to SLS, and on this point I want to be crystal clear, SLS is not reusable. But it is a critical piece of the architecture that enables us to deliver reusability to the moon. We're talking about launching Gateway and Orion and the European Service Module. All of these things are part of a reusable architecture. We're talking about a rocket that's bigger than any rocket that's ever been built in human history, with a payload fairing capable of carrying volumes that we've never seen before, taller than the Statue of Liberty. To take our, not just astronauts to the moon, but at the same time, co-manifested payloads at the same time. This is a transformational strategic capability for the United States of America. And I want to stop for just a second and let you know this. SLS and Orion and Gateway and in low Earth orbit, the International Space Station, commercial crew, commercial resupply, and commercialization of low Earth orbit for habitation, all of this is very strong in the President's budget request, and we are thrilled as an agency that he is backing up not just with Space Policy Directive 1, but with his budgets. And this is going to help us build that sustainable return to the moon. One other very exciting thing I need to make sure everybody is aware of when we talk about our moon activities. For the first time in over 10 years, we have money in this budget for a return to the moon with humans. I'm talking about human-rated landers, compatible with Gateway, that can go back and forth to the surface of the moon. We are funding human-rated landers to go to the moon for the first time in over 10 years. Okay, so we have a really special opportunity now. I'd like to let everybody know that we're going to go live from the Johnson Space Center, where we're going to meet astronaut Karen Nyberg. Karen is going to take us through the inside of a mock-up of the Orion crew capsule that astronauts will use to fly to the moon.
Thank you, Administrator Brian Stein. I'm astronaut Karen Nyberg, and I'm here at the Johnson Space Center, as he said, inside a test version of the Orion capsule. Over at KSC, you, of course, are seeing the real hardware, what is going to fly crews to space, to the vicinity of the moon. This is actually a volumetric mock-up. It's the same size, what you would expect, what the Orion is. We've been using it quite extensively here at the Johnson Space Center for engineering and operational evaluations. And you really get a sense when you're sitting in here, when you get inside, what it's going to be like for the crew when we actually start taking it to the vicinity of the moon. I'm sitting here next to the commander's seat. The commander would be sitting here to my left, and in front of us are the displays. We have three screens that we can switch depending on what phase of flight we're in. We can pull up any number of displays. Here we monitor all of our systems, communication, prop, our eclipse, our electrical system. We can monitor our attitude in space and also our trajectories, and then also send commands from here as well. It's quite slick. Above my head, you'll see we have several windows, which I think is a key component for any vehicle that is going to carry people. And I'm sure this is going to provide a great view of the moon for folks as they're getting near. It's really an exciting time for everybody at NASA right now. Not only are we building Orion and SLS, but at the same time we're continuing to do the work and living on board the International Space Station, doing research for investigators all over the world. We're also demonstrating some hardware on the space station, and of course fostering the commercial participation in space travel. And at the same time, getting ready in the development of Gateway and the Lunar Landers and all of the science payloads that are required to establish that presence there is really, really exciting for all of us. I have with me here to show this is a lunar sample that was actually brought back from one of the Apollo missions, and this one actually flew on a space shuttle to the space station. And we're really excited as crew to be able to bring back samples like this for scientists to study again, and eventually samples from Mars. Back to you, Administrator Bridenstine.
Well, Karen, thank you for that brief and that update. Can you share with us as an astronaut, and I know you're working with the astronaut corps all the time, with all of these different capabilities that are under development right now and in fact now testing. Of course, we've got the Dragon, we've got the Starliner, and now we've got Orion. Do the astronauts fight over who's going to fly which vehicle?
I don't know if we fight over, but I think everybody has in their mind they want to fly something. I think we're in a unique position now with so many different vehicles to fly on, and I think most crews are just happy to get a spaceflight assignment.
Well, Karen, I just want to say thank you for that. I'm going to talk for just a second about that lunar sample that you have in your hand. We have a very special announcement today. We have 3 lunar samples that have come back from the moon that have never been opened. We're going back to our missions from 1969 to 1972, 6 missions. We have 3 samples that have never been opened. And in this particular budget and in this particular year, we are very much looking forward to contracting with 9 different companies to have the opportunity to use the technology we have today to study those very pristine samples that have never been opened. Now, I want to be clear. Here's a critically important piece of knowledge that we need to understand. When the previous generations did Apollo, they knew that the technology that they had in that day was not the technology that we would have in this day. So they made a determination that they were going to preserve samples, because they knew there would be a day when better technology would be able to better assess all of the different the history of the moon from ultimately the technology that we have today. So today we have this very special announcement that we have 9 teams that will be examining 9 unopened samples that have come back from the moon, and we feel like we can do that because there are more lunar samples on the horizon where we're going to be able to learn more about we've ever learned about the moon before. So I'd like to thank, if it's okay, the Apollo generation for preserving these samples. So that our generation could have this opportunity. Karen, thank you for your great feedback on what's happening there at the Johnson Space Center. I want to talk for a second. Oh, yes, please. I want to talk for a second about the Gateway. One of the valuable capabilities that the Gateway is going to bring is a plus-up in solar electric propulsion. We're talking about the ability to maneuver. Now, the Gateway is not the International Space Station. That's an important thing to remember, because we want to be able to have it maneuverable around to go to all parts of the moon. And in order to do that, it can't grow too big. The mass has to be constrained. So that we can use solar electric propulsion, which has a very high specific impulse. In other words, it can be used for a very long period of time for sustainability. To be able to go again to the poles, both the north and the south pole of the moon. Could we bring up a picture of the Gateway? So when we think about the Gateway, I just want to show you this is an aspirational vision of the Gateway. This is not what it is right now today, but this is aspirational. And I can tell you, just this morning, I got off the phone with all of our international partners on the ISS and others, and they are very excited about partnering with us on going to the moon. A couple of weeks ago, we announced that Canada is stepping up for the next 24 years to partner with us on robotics on the Gateway. Now, the Gateway is not going to be crewed 24/7, 365 the way the International Space Station is, which means robotics is a critical piece of it. And of course, with Canada coming on board, which is the first official partner on the Gateway, we're very excited, and we know, based on other conversations, that we have other agencies all around the world excited about partnering with us on Gateway. Here's why this is important. NASA is very unique in all of the federal government. We're able to have partnerships with countries that in some cases we wouldn't normally be able to partner with. You can see on there, Roscosmos. The relationship between the United States and Russia, of course, is strained terrestrially. But since 1975, the height of the Cold War, we have been able to live and work together in space. 1975, of course, was the Apollo-Soyuz program. Of course, when I went to Russia, they called it the Soyuz-Apollo program. And then, of course, the Shuttle Mir program, or as they would say, the Mir Shuttle program, and now the International Space Station, and in the future, on the Gateway with other activities as well. But it's not just about them, it's also the European Space Agency, it's the Japanese Space Agency. And what we want to do with the moon, when we think about this architecture, the Gateway is not the end state. The Gateway is a piece. The end state is all of the above. Access to space, not just low Earth orbit, but deep space. Tugs that can go back and forth from low Earth orbit to lunar orbit. The Gateway itself, which of course is this reusable command and service module in orbit around the moon, and reusable landers, as I've mentioned, which are funded in this budget for the first time in 10 years, that can take humans back and forth to the surface of the moon reusably, but also robots and landers and rovers. When we think about this architecture in the future, we don't want to constrain ourselves to the traditional International Space Station partners. We love them and they're going to be with us and we are thrilled to have their support. But there are other partners. There are more space agencies all around the world than ever before in human history. And of course, as we are now starting to see in a more robust way, we have commercial partners that are bringing capability to us as well. So this is just a snapshot of the future. It's not where it is right now, but I believe in the future it'll look something like this. And in order to talk a little bit more about the Gateway, I'd like to go to the Glenn Research Center, where we have Deb Waters and Dave Jacobson. Dave is the Chief of Electric Propulsion Systems, which is a key capability, and Deb is a Facilities Manager there at Glenn. And I'd like you to share with us, if you will, just a few minutes about what's happening with solar electric propulsion.
Hi, I'm standing here in the high bay of the Electric Propulsion and Power Laboratory, where we're getting ready to perform technology development that will take us forward to the moon. Here at Glenn, we have a rich history in electric propulsion testing. We've been conducting research, development, and experimental testing in our facilities for over 60 years. Right now, we're getting ready to test the type of system that will take us forward with the Gateway, the new spacecraft that will be in orbit around the moon. My colleague Dave here is an expert in electric propulsion. Dave will take it from here.
Thanks, Deb. A team here at NASA's Glenn Research Center is working in collaboration with our colleagues at the Jet Propulsion Laboratory on the development of a high-power solar electric propulsion system in support of deep space exploration missions. The intended application for this technology is the Gateway that Deb and others have referred to today. The Gateway will enable crew to live and work in deep space for months at a time and serve as an outpost for human missions to the lunar surface. The power and propulsion element will be the first part of the Gateway, and it will provide power, propulsion, and communications during the assembly and operational phases of the Gateway. Gateway will utilize solar electric propulsion to maintain its position and also move between lunar orbits. Back in 2012, we began working on high-power Hall thruster system technologies in support of an affordable, beyond low Earth orbit, human exploration architecture. The hardware that you see here in front of me resulted from that project. A Hall thruster ionizes neutral xenon gas and accelerates ions at high exhaust velocities to create fuel-efficient thrust. The power processing unit takes power from the solar array and it converts it to the currents and voltages necessary to operate the thruster. Today we're preparing to test an advanced electric propulsion system that operates at a power level 3 times greater than systems that are currently used on orbit. It also operates with greater fuel efficiency and for longer lifetimes than those types of systems. This is very important for Gateway. Let's go inside the vacuum chamber now with Deb.
Right now, we're inside BF6. This is actually the largest chamber at Lewis Field, vacuum chamber at Lewis Field. Behind me is a thruster. It's an engineering model. Around it is a thermal shroud. This thruster is getting ready to test actually next week. We're going to be working on the various probes before the flight model comes sometime in May. Our facility, before we can actually run the thruster, we have to button up our facility and we actually have to pump out all of the air. We do that with very large vacuum pumps both inside the chamber and outside the chamber. The chamber walls can be actually chilled down to minus 320 degrees Fahrenheit, and you can see that the chamber is actually lined in graphite. The reason for that is that this is an electric propulsion chamber. The thruster plume is energetic enough to actually erode the walls of the chamber, and that graphite minimizes both the damage done to the chamber as well as that chamber material coming back and landing on the thruster itself. So it minimizes the damage done. In order to create a space environment such as this, we try to do all of these things that make the facility more like a space environment that you would see at Moon, Mars, and beyond. VF6 is just one of 27 chambers we have here, space simulation facilities we have here at Glenn. And VF6 actually is the largest electric propulsion capable chamber in the world right now. We're very fortunate we get to test these different types of power and propulsion systems as we're getting them ready to fly. It'll be great to be able to see this running next week, right, Dave?
That's right. At NASA, we like to say that technology drives exploration. Here at the Glenn Research Center, we're very excited that electric propulsion is a part of our sustainable deep space exploration missions. We look forward to applying our expertise in solar electric propulsion to human and robotic missions to the moon and beyond.
Back to you, Administrator.
Nice work, Dave and Deb. You're getting applause if you can't hear it. I got a question for you guys, just real quick before you leave. What's the next major milestone in this propulsion development?
Sure. So the hardware that I showed you earlier was designed and built by the Glenn and JPL team to demonstrate feasibility of this technique for the Gateway. In 2016, we selected an industry partner who is finishing the development of the system and also qualification for Gateway. In the May timeframe, I think Deb might have referred to that hardware, we'll be receiving the first engineering technology units, and we'll be conducting development testing, including functional, performance, and environmental testing, all in support of the Gateway.
Awesome. Last question. When we think about the next human outpost in space, in orbit around the moon, it's starting in Cleveland. How do the folks of Cleveland feel about being at the forefront of this opportunity?
I think I'll speak on behalf of the entire team here at the Glenn Research Center. We're so excited to be a part of this. Folks have worked in this area literally for decades. Back to this chamber was put here in 1961. So yeah, we're beyond excited to bring that expertise to bear for such an important thing for NASA.
Well, Dave and Deb, thank you for your great work. Make sure everybody there knows how grateful we are, and we look forward to making this really a winning achievement. And thank you for your good work.
Yeah, thanks for the opportunity.
So we've talked today a lot about the moon. And we have all heard the President's Space Policy Directive 1, which I am charged with carrying out, that today's budget announcement enables us to achieve. To go to the moon sustainably with international partners and commercial partners, to utilize the resources of the moon. In other words, the hundreds of millions of tons of water ice that we've already discovered. Water ice is air to breathe. It's water to drink. It is, in fact, propulsion, and it's available in hundreds of millions of tons on the surface of the moon. But it's about more than just those things. The last part of his first Space Policy Directive says to take these capabilities for an eventual mission to Mars. So what we're trying to do is prove capability, prove technology, retire risk, make sure that what we develop is not a dead end, and in fact has capabilities of being utilized on another world. That other world, of course, being Mars. let's talk for a second about Mars. And by the way, when we're talking about Mars, let's start talking about the Science Mission Directorate, the Planetary Science Division of the Science Mission Directorate. Here's what we know about Mars. Because of Spirit and Opportunity, we now know that Mars was at one time covered with water. In fact, its northern hemisphere was 2/3 covered with water. And in fact, there was flowing water on Mars. Because of the MAVEN orbiter, we now understand ultimately what happened to that atmosphere on Mars. When you talk about an ocean, what you mean is, yes, there was an ocean, but that means there was a thick atmosphere as well, and at the same time, that means there must have been a magnetosphere protecting Mars from all of that radiation coming from the sun and from deep space. We know that to be the case now because of Spirit and Opportunity and MAVEN. All of these things collude to say that at one time in Mars' history, it was habitable. I'm not suggesting that it was inhabited, but it was habitable. And here's what we know now. Because of the Curiosity rover, we now know that there are complex organic compounds on the surface of Mars. And by the way, that discovery is just in the last year. We now know in the last year that the methane cycles of Mars are perfectly commensurate with the seasons of Mars. Complex organic compounds, friends, don't exist on the moon, but they exist on Mars. And of course, they're all over Earth. They are the building blocks of life. The probability that we might find life on another world has gone up. When the methane cycles are commensurate with the seasons, again, it doesn't guarantee that there's life, but the probability of life on another world just went up again. Now, I'm not talking about bunny rabbits, I want to be clear. I'm talking about microbial life. And I think it's important, and this budget funds our ability to reach out to another world and find potentially life on another world. So how do we do that? This budget fully funds Mars 2020. This is an amazing capability. For the first time, we are going to cache samples of Mars for an eventual return. We're also going to figure out how do we use the carbon dioxide of Mars to create oxygen that eventually humans will be able to breathe. And even more exciting, we are going to, for the first time, fly a helicopter on another world with the Mars helicopter. Mars 2020 is fully funded in this budget request, but even more, a Mars sample return is also funded in this budget request, which we are very excited about. The moon is the proving ground. Mars is the horizon goal, and it requires an all-of-the-above approach. I'm going to anchor on the Science Mission Directorate for just a second because I need to give a lot of credit to a lot of people. When I was home over the holidays, a number of very important things happened. OSIRIS-REx entered orbit around Bennu, the smallest object that we've ever been able to orbit in human history, and because of that, we're going to have this little robot ultimately do a sample return from Bennu, an asteroid in deep space. And just a few days later, we flew by Ultima Thule with New Horizons, 4 billion miles from Earth, on the other side of Pluto in the Kuiper Belt. And we're getting beautiful images of this asteroid in the Kuiper Belt that is a binary contact. And of course, before we did this flyby, we had no idea what this object would look like, but now we know. And we're getting valuable scientific information. The Science Mission Directorate, friends, in this budget is funded very, very well, and it is in fact healthy. So that takes us back to this all-of-NASA approach. If we're going to fly humans to Mars, what other parts of the Science Mission Directorate do we need to fund and understand? Well, if we're going to take humans to Mars, they're going to have to travel through deep space. One of the most dangerous elements of deep space is, of course, the radiation that comes from the sun and radiation that comes from deep space. We need to better understand how the sun puts this radiation into space. We need to be able to, in fact, predict solar flares and corona mass ejections. Because if we're not able to predict that and our astronauts end up in the middle of something like that, it could be very damaging for their health. So when it comes to heliophysics, Parker Solar Probe is fully funded, and of course we are following the guidance of the decadal surveys for heliophysics so that ultimately we can understand how the sun interacts with the Earth, other planetary bodies, and ultimately be able to predict so we can provide protection for humans here on Earth, not just on Mars. To be clear, I want to be clear on this. If we have a corona mass ejection, like a Carrington event in the 1800s, it could be very damaging for humankind. Imagine not having the power grid work or your cell towers work. That could be existential. So we need to be very good at being able to predict when these kind of events are going to occur. And within the Science Mission Directorate, we are funding those capabilities with the Parker Solar Probe and others. That takes us out from the sun to the Earth. The President has now signed into law the highest Earth science budget in the history of the United States of America. Every year he has been the President of the United States. And this budget request is higher than 5 of the budgets that came out of the previous administration. When I came to NASA, I committed to Congress, and I commit to you now, that the Earth Science Division of the Science Mission Directorate would be strong. That we would move forward, no kidding, with the decadal surveys that come from the National Academy of Sciences in all of their agenda items. Starting with understanding the interaction with the water cycle and the energy cycle. Ultimately being able to predict weather and air quality. Understanding natural disasters and how they occur. When we think about ecosystem change, which, friends, it is changing. Carbon dioxide is in the atmosphere in levels that we've never seen before. We are responsible for that. It is a greenhouse gas. NASA has an obligation to continue studying these activities. We want to reduce climate uncertainty. And what we do when we study the planet is we sense the Earth in every part of the electromagnetic spectrum, and we share that information with the world, and we do it for free. NASA is an agency. We don't do policy. We don't make recommendations about what to do with what we learn, but what we do is we study the Earth. And as I committed from the beginning, we are studying the Earth with as strong a budget as we have seen really in a very long time right now, and this budget request for Earth science is very strong as well. Talk about astrophysics for a while. Talk about some exciting discoveries. You know, what's amazing is we're learning more about not just our solar system, not just about our galaxy, but in fact about the entire universe all the time now. We're discovering new planets around other stars. The Decadal Survey for Astrophysics wants us to see, no kidding, the beginning of the universe, what we call cosmic dawn, to see the first light in the universe, light from stars, light from galaxies, to even assess the earliest black holes. And friends, we're starting, because of these capabilities that have been launched in previous decades, we're starting to understand physics, astrophysics, in a way that previously was only theory. And for now, for the first time, we're proving out the reality of the theory of relativity, Einstein, and all of these other things. We're seeing it for the first time. What we now know because of these missions, we talk about Hubble, and Chandra, and Spitzer, and Kepler. We now know that the universe is not only expanding, but it's expanding at an ever-increasing rate. It is, in fact, accelerating. And the question is why? And we talk about things like dark matter, which we now know is most of the matter in the universe. We can't interact with it, we can't see it, but we know it's there because we can see its gravitational effects. And of course, when we talk about the acceleration, usually matter has this gravity and it pulls things together. But instead, the universe is accelerating faster and faster away from this point. And so we use words like dark energy is causing this to happen. Well, in order to learn more about this kind of activity, we need to be able to see to the very beginning. We need to be able to see that cosmic dawn, the first light in the universe. And I will tell you, it has been a challenge for me as your NASA administrator to go up to the Hill and talk about the James Webb Space Telescope. Some of you might have seen those hearings, and they're not fun. But I will also tell you this. This administration is committed to the James Webb Space Telescope, and we have bipartisan support for the James Webb Space Telescope, and it is our agenda, our #1 agenda for James Webb is mission success. We can talk about budgets and we can talk about schedules, but at this point, this mission is so important to the United States of America, and here's why. We're talking about establishing America as the lead in physics for the next 30 years. When James Webb Space Telescope is launched and we're able to see cosmic dawn, it establishes the United States as the leader of physics for the next 30 years. But it goes beyond that. Sure, we want to lead, but we also want to discover. We have models and ideas about really what the universe looked like in those days, but we're going to know. And I can tell you this, here's what we already know, the models aren't right. So this is an exciting time. The other thing that's important, that this comes straight from the decadal survey, we want to be able to look at other stars. And not only look at those stars, but look at other planets around those stars and characterize those planets as to their habitability. Could those planets be able to host life? And James Webb is going to give us an opportunity to look at the light as it transfers through that atmosphere. Certain parts of the spectrum are not going to make it through, and we're going to be able to determine the atmospheres of planets around other stars and make assessments as to characterize, if you will, the atmospheres of those planets. James Webb is going to be an amazing capability for the United States of America. As we're on astrophysics, I also want to make one last statement that I think is important. We talked about the gateway and how it's going to give us access to the surface of the moon. We want humans on the moon. We want robots and landers and rovers. We want to get to more parts of the moon than ever before. The gateway is not just about getting to the moon. It's not just about studying the moon from an orbit around the moon. The gateway gives us an opportunity to study deep space from a human-tended space station, which gives us a capability that heretofore we've never seen. Here's what we know. On the far side of the moon, it is very quiet. Why is it so quiet? Because all of the electromagnetic radiation that we create, it's quiet on the far side of the moon. So we can image deep space in parts of the electromagnetic spectrum that we can't currently image deep space with. And by the way, it's not just gateway, but it's also surface activities. We can do astrophysics from the surface of the moon with very thin wire antennas. Now that's maybe not in this budget request, but the gateway opens the door to all of these capabilities in the future. So in closing, I want everybody to know that NASA's budget request is very good. And we have bipartisan support, which I have been committed to from the beginning for NASA. Not just in the House, but also in the Senate. And we're going to be able to accomplish more than we've ever been able to accomplish before because of the administration support and bipartisan support. So what does that mean for us? Friends, we need to make sure that when we consider our agency, I just talked about heliophysics and how important it is if we're going to send astronauts to Mars. How important is heliophysics to the lives of those astronauts? But just not those astronauts, but also the landers and the rovers and the robots. That means heliophysics is a critical piece of our moon to Mars capability. And it goes beyond that. I was in the hotel this morning and I was talking to a lady who had the opportunity to visit the Kennedy Space Center. And she said one of the things that was most striking to her, and Bob Cabana, this is a compliment to you and your whole team, she ran into somebody at the Kennedy Space Center and asked him what he did. And he said, well, I'm helping us go to the moon and on to Mars. That was his answer. And she said, okay, well, what do you do? And he said, I'm a custodian. Friends, these objectives are an all of NASA approach. Every center that we operate, all 10 of them, are critical to this mission. And every mission directorate is critical to achieving these goals, including the Mission Support Directorate. We talk about the infrastructure, and in some cases, infrastructure often becomes a target. But friends, we can't accomplish any of these objectives without the infrastructure as well. So the Mission Support Directorate is also a critical capability for our shared achievement in heading to the moon and on to Mars. So I just want to share with you one last thing. For all the people that are watching, I see a lot of TV cameras and maybe some social media. I want to encourage everybody to visit nasa.gov/moon to Mars. nasa.gov/moon to Mars. I want you to go to the website and I want you to learn. For the NASA employees here, I want you to figure out how you can communicate all of these great things that we are trying to achieve to the public. Engage on social media. I want you to engage on social media. If you have Twitter or Facebook, or just talk to your friends, make sure you are letting them know what we are doing and why. Because this is transformational. And it's only going to happen if all of America buys in. The other day I went to the World Ag Expo. And everybody was like, why is the NASA administrator going to the World Ag Expo? I'll tell you why. Because we need all of America to understand how we have changed the human condition. When it comes to agriculture, we're sensing every part, the Earth and every part of the electromagnetic spectrum and sharing that with the world. Well, who needs that? Farmers sometimes need that. We have an agreement with the Cooperative Extension of the University of California where we're taking that great information and sharing it with them to the point where they are able to increase crop yields while reducing their water usage by 25%. And by the way, in the desert of California, that is a big deal. And at the same time, because they're not watering so much, preserving 50% of the nitrates that normally would have eroded into the water supply. Those nitrates help the plants grow, and guess what? When they're in the water supply, they're very bad for humans, and it costs a lot of money to get them out of the water supply. So we're saving money, increasing crop yields. The plants are doing much better because the nitrates are actually in the soil where they ought to be. And they're able to achieve these because the Earth Science Division of the Science Mission Directorate is providing this data to the Cooperative Extension of the University of California in a small scale. What does this mean for the future? When I was at the World Ag Expo, I talked about doing it for Uganda. Uganda was able to use NASA technology to be made aware of a drought that was on the horizon. We can detect plant stress long before humans can detect plant stress. We can do it from space. And because of that, instead of spending tens of millions of dollars doing disaster relief, we spent a couple of million mitigating the disaster before it happened, saving lives, saving money. But friends, it's not just about crops, although crops are a critical piece. The way we communicate, DirecTV, Dish Network, internet broadband from space, XM radio, sending high-resolution motion pictures all over the world for national security and defense, communications, born from this little agency we call NASA, space-based communications. We talk about how we navigate with GPS, how we produce food, which we just talked about, how we produce energy, Geocarb, another Earth Science Division mission that is helping us make sure that as we produce energy, we're not polluting the atmosphere. And that, by the way, the energy companies love that because then they don't get fined, which is a good thing. The way we do weather prediction, and understand the climate, the way we do disaster relief and national security, the way we do banking. All of the banking transactions in the United States of America are dependent on a timing signal from GPS. A lot of people don't realize that. The way we regulate the flows of electricity on the power grid, dependent on a timing signal from GPS. Terrestrial wireless networks, dependent on a timing signal from GPS. When we think about how we have elevated the human condition, this little agency that constitutes less than one half of 1% of the federal budget, this little agency has elevated the human condition in ways that most people don't even know. It's on us to let them know. It's on us as the NASA employees, the NASA workforce. That includes our contractors as well. Let them know what we are doing to elevate the human condition, not just for the United States, but for the entire world. This is an amazing agency. And I got to tell you, I am overwhelmingly humbled every day when I get up and I have the opportunity to interact with the just amazingly talented people that work here. So I want to say, know this. NASA is going to get a healthy budget. The administration is supporting it. We've got bipartisan support in the House and the Senate. What we've got to do is make sure we communicate it to the world and ultimately keep it strong for the future. And the only way we do that is communicate it to the world. Again, nasa.gov/Moon to Mars. Thank you so much. It's great being here at the Kennedy Space Center.
I would like my social media team to exit. I would like any subject matter experts who are manning those tour stops that these people are going to go ahead and exit now. And then just hold tight to everybody else, and we'll let you go out in a second. In media, you're going to stay put. You're going to have a gaggle in a second. And as soon as you guys clear, all the other employees will start going. Feel free to mingle in the lobby, just not in here.
Can I get on and talk to Mike?